Wait, Johnny, I'm going live.
Oh my gosh, is that a flippin'? What is that?
All right.
What is that?
Thank you for joining me. We now have an enhanced risk for northern Louisiana and southernmost Arkansas and easternmost Texas and westernmost Mississippi is under enhanced risk of severe weather. What is being maxed out here is wind and tornado risk. See, severe potential, including tornadoes, remains evident for parts of East Texas to the lower Mississippi Valley area Tuesday night. So, let's read this. Portions of eastern Texas across the lower Mississippi Valley. Thunderstorms and possibly limited severe risk will be ongoing at the start of the period across portions of central Texas. Strong southerly flow from ahead of the advancing what? Cold front? Okay, strong southerly flow ahead of the advancing cold front will continue to advect Gulf moisture northward through widespread elevated convection to the north will likely tend to hinder most robust northward advance of the true warm sector. This looks kind of weirdly worded.
Weirdly worried?
Yeah, I think it would, hold on. Will be strong southerly flow ahead of the advancing from will continue to advect go. Okay, from will. So basically, they're saying that Gulf moisture will go north. Okay, with that said, minimal heating combined with the moist low levels will result in modest Cape increases through the day, with storms moving across East Texas is expected to gradually intensify in response. Given very favorable shear, veering and increasing substantiability with height, rotating updrafts are expected. Both with the primary likely to be linear band of storms, which means a squall line, and any more isolated cells which may develop ahead of the main band, along with risk for damaging winds, tornado risk. Oh, let's see. What? Yes, Johnny. Yeah, thank you. I responded, Johnny.
I didn't see it.
I did.
I didn't see it.
On TikTok. I mean, I responded.
No. Andy. I'm talking about on Cash App, you silly boy.
Yes, I know. $2. I know. For the Tuesday. To help you with Tuesday. But here's the problem, Johnny. I'm working on Tuesday.
Dang it. Well, what time you gonna get off?
Well, the problem is it's going to be in the evening. So if I do help you, it's probably going to be during my break or if I get off early.
Oh, man. Hashtag rip. Rip in the chat.
But I will help you, though.
Really?
When I can, I will.
Wow, that's amazing.
But when I'm going to be getting off at work is when all the storms will start to fire up.
Oh, so okay. On Tuesday, what day do you think? I mean, what time of the day do you think I should go live?
Let me check the models. Okay. So the NamNAS is usually really accurate. About 8 p.m. No, not 8 p.m. Like 7 p.m.
Oh wow.
That's my time. Like 5 your time. Like 5 or 6 your time.
So that's about the timing I should start to go live.
Yeah, and it doesn't look like it's going to be really bad. It just looks like a squall line, basically.
A squall line, bruh. Do you not know how severe a squall line can be?
Yeah, but it doesn't look too bad. At least not. Let me check the HRRR.
Wow, I see.
Oh, that is bad. Okay, Johnny. I would say about 7 p.m. You should, like 6 p.m. You should go live.
So around 7 p.m. is when I should be going.
No, 6 your time.
Really?
Yeah, they're showing supercells in Louisiana at 0Z, which would for you be, I think 7 p.m., 6 or 7 p.m. Let's see what time it's currently in England.
Oh my God, Andy!
Huh?
Do you remember that video that you made 2 weeks ago about the severe weather event?
Yeah, John, you need to go. You need to go live around 5 p.m.
Okay, good. You got 645 views, by the way.
Thanks, you, Johnny. But right now, I need to focus on the weather because people. I'm live right now, Johnny.
You got 6 people watching you right now. How does that make you feel?
Really good. Thank you. Thank you all for watching.
I shouted you out.
Thank you, Johnny. Okay. I hope you didn't shout me out on YouTube because I don't want you to get another strike.
I did.
Johnny, you're going to get another community guideline strike. Don't sacrifice your YouTube for me. I'm not worth it. Johnny, I mean, it's not worth it.
Oh, wow. Look at your view spike. Look at your view spike.
I know.
That's crazy.
Well, because I'm having 5 people watching. Johnny, I don't want you to get in trouble for my sake, you know. Your channel is really important. I don't want you to lose all your... I know you want to really help me, but thank you so much, Johnny.
Wow, that's pretty flippin' neat.
Okay, here comes the Euro. Here comes the GFS.
Wow.
So you see this upper level low? You see this little thing right here?
Look at the view spike. That's crazy.
Yeah. So, Johnny, so the reason New York is getting snow is because of this little cold pocket.
Oh my God, Andy! Oh my God, Andy!
What? What?
No frickin' way.
What?
No flippin' way.
What?
I am sending you this right now. Dude. I got an ad on your video, dude.
Johnny, I know you have an ad. Can I explain why? Even though my channel isn't monetized, YouTube is still making money.
I wish I had ads.
No.
Oh wait, YouTube took that ability away.
Huh?
YouTube took my. You don't remember when you don't remember YouTube took away the ability of me making money?
No. Johnny, my channel isn't monetized. All the money from my videos go directly to YouTube. Yeah, right. YouTube makes the money, not me. So okay, so right now I'm looking at the live stream So okay, hour 135. This is kind of disappointing. Yeah, this is disappointing. Yeah, looks like it's gonna be mostly rain for New York City.
Mostly rain for New York.
Yeah, so this is 18Z and 0Z. Yeah, it's gonna be rain for New York City.
If only there was that much thing. Wow. I cannot believe it. I cannot believe it, man.
Hold on, Johnny. Let's see. Hour 240. Oh, damn it. Look at that. That sucks.
Wow.
Ooh, this looks interesting.
What looks interesting?
Around hour 384.
384?
Yeah, look at that.
I see. We must We must. We must.
Mm. Unfortunately, I don't see a lot of snow and cold for you, but oh
Dang
wait,
it. That figures.
oh 1 point. Look at that, a little bit of snow. You might get around Saturday the 17th. Northern Louisiana might get some snow.
Well, dang it. Well, South Louisiana needs to get some snow.
Yeah, I know. I really hope you'll get some.
Let's see. Let's see here.
That's a polar vortex coming down. Look at that.
I see that. You need to do another one of those forecasting videos like you did 2 weeks ago. That got you 645 views.
So right now the PNA is going to be trending positive.
Andy.
Yes, I know. I hear you. So the PNA is going to be trending positive. You see all this warm weather going into the West Coast. That is a positive PNA.
PNA?
Yeah. Okay. So this is the PNA here. Positive PNA would cause ridging over the West Coast, troughiness on the east. So this is a positive PNA right here, and also with a blocking, with a negative Arctic oscillation right here. Yep, that's a polar vortex right there. You see this 5100 line? That's a polar vortex. Right here, see all that whiter color? So that's the polar vortex right here. And then a piece of it breaks off. So that's a very disrupted polar vortex. Yeah, so this is looking really bad for Louisiana. Northern Louisiana. Yeah, Alexandria is going to get screwed. Shreveport. Yeah. This just shows a thin little line of storms. Like, nothing. It's just a little line. Right? But the HRRR, it goes gangbusters. It literally shows supercells just south of Shreveport. Yeah, so that's definitely scary. Thanks, dude. Yeah, I mean, okay, Johnny. I want to stay up for the Euro, but I have to get up at 8:30 in the morning. Yeah, I have to get up at 8:30. Unfortunately.
Dang, that sucks.
I mean, I guess I could stay up until maybe 2:30 and wait for the Euro to come in.
Yeah, that's a massive rip.
What?
You having to get up at 8 a.m.
Yeah.
So you gotta go to work at that time?
I have to be at work. I have to be at work at 9:30.
At 9:30, huh?
Yeah, Johnny. Welcome to the real world. You know. Whoa! Look at that cold blast.
I see that.
Yeah. Boom! Polar vortex time. Boom! Look at Christmas. Holy crap!
What? What about Christmas?
Wow, it's gonna be freaking freezing.
Freezing? How freezing? It's not going to be that cold.
Yeah, the only reason it's not gonna be that cold in New York is because of the Appalachians. But damn, if we didn't have those Appalachian mountains, in New York City it would be like 10 degrees below zero.
10 degrees below zero.
If it weren't for the Appalachian Mountains, you know, the rain shadow effect, as air sinks it warms. But damn, if that model verifies, damn. Whoa, look at Chicago, negative 10 degrees.
Negative? Is that a real forecast?
It's a model forecast. I mean, it shows Louisiana getting into the 20s. It shows Louisiana being in the teens.
What part? What part?
It shows freezing temperatures all the way down to the Gulf. It shows.
Oh, man, it expired. Dang it.
Go to hour 300 on the GFS.
Hold up, I am. Hold up. Continental U.S. local. Oh, that's stupid. Oh, that figures.
What?
The Pivot Weather Plus. It's gone.
Yeah, it was a trial. You have to buy it.
That's a ripoff.
Yeah, you have to pay for it. I used to pay for it, but I ran out of money, so it expired for me too.
Oh, my, that's scary.
What?
Uh, temperatures of 7 degrees in Louisiana? I think not.
Yeah, I mean you never know. I mean,
Yeah, the temperature goes as far south as the Gulf of Mexico. Oh, heck no.
well, Johnny, if the PNA goes positive, this is what I wanted to show everybody.
Right.
If this happens, you see how the PNA is going up, 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 up? If the PNA continues to go up, and with the AO being negative, look where the AO is, Johnny.
I don't see it because it's delayed.
Okay, wait a minute. Just right now, the Arctic oscillation is -4.
-4?
Yeah, -4. We're going to have major storms.
Can you define by major storms?
Blizzards, nor'easters, like for the East Coast.
Blizzards?
Yeah. Especially once the PNA goes positive, all hell's gonna break loose.
I see. Let's see what kind of Morganess is going on here today.
East, you're gonna have a lot of coastal storms.
Let's see. CMC. I wonder what the CMC say. I can't believe that the Weather Channel saying I'm going to be getting snow Saturday. I can't believe it.
Johnny, I would not put your bets on it.
Yeah, you're right.
I really wouldn't.
Let's see. I'm gonna see if it changed. Cause I don't know how often the forecast model changes. What am I trying to say? The forecast changes. Oh, damn, darn it. Now it says no snow.
Johnny, I told you there wasn't gonna be any snow.
Well, now I'm a depressed boy.
Johnny, I told you there wasn't gonna be any snow, but you didn't believe me.
No. I'm saying the forecast on the Weather Channel.
I know, Johnny. I know.
Dang, I get my hopes up for nothing.
Johnny, did I tell you not to get your hopes up?
Yep, you did.
Exactly. Don't get your hopes up.
Come on, NBC, update already, you stupid app. They so slow pokes at this. check it. Or they can't change it. What am I trying to say? What? Whoa. Okay, that looks mighty scary. Wait, I know what to check. Aha! Bingo, what is his name out? I'm going to check this. Can you go to the GEFS and go to the Southern United States? Andy,
Huh?
can you go to GEFS and click the Southeast?
Yeah, it's. I know. You want to look at ensemble member 7.
Yep.
Hmm.
I want to see it. Yes. Hmm. Wow. How about that? Visibility 440 yards. What the heck does that mean? Uh,
Well, it doesn't show any snow from Baton Rouge. It shows most of the snow in Alabama.
dang it. That sucks.
See, ensemble member 7, Southern Louisiana.
What?
Are you
Yeah.
north or south of Lake Pontchartrain?
No. South of Lake Pontchartrain,
Are
huh?
you north or south of Lake Pontchartrain?
Neither. It's like right in the middle.
Mm.
Yeah, I see. I mean, that's look at ensemble model number one. That shows some like dusting.
You're actually more
Wow.
likely to get snow with ensemble member 1.
Wait, I'm watching to get it with a what?
You're more likely to get snow with ensemble member 1 if that were to come true. Gonzalez. Okay, so based on what I'm seeing, you would get a little bit of snow if 7 were to happen. Like if that were to actually happen, you would get a little bit of snow. Not a lot though.
Wow, I see, I see. That's pretty damn neat. You got 9 people watching you right now. How does that make you feel?
That makes me feel nice. Thank you, Johnny.
Well, I told you to not get so discouraged. There you go. I helped you.
Thanks, Johnny. New York City sucks. No snow in New York.
Rippity, rippity, rip. Come on, SPC. Update already.
Huh?
I don't understand what takes the SPC so long to update. The day 2. I want to see day 2, but it's taking too long to load. Hmm. That is a large swath of winter storm warnings.
For where?
Oh, wait, that's one. Never mind. Hey, winter weather advice. Hmm. I heard that was down here. That would make me think. I'm starting to gain confidence that chancellor is going to shift south. I think that's what's going to happen. Uh, uh, the highest directed damaging wind threat.
Hmm.
That's
Hold on. 10 to 18 inches of snow.
what?
Hmm.
Oh, you use the same website I use. Weather.com. Okay.
Blizzard warning in effect.
Blizzard, where?
North Nebraska.
Man, that Nebraska.
Blizzard conditions expected. Total snow accumulations of 10 to 18 inches with locally higher amounts and ice accumulations. That means freezing rain. Around a tenth of an inch. Winds gusting as high as 55 miles an hour. Damn.
Sir, okay, okay.
Hold on.
Let's see.
Travel will be very difficult to impossible.
Eric,
What?
can you go to where it says local weather forecast by city, state, or zip code and type 70754, please?
I already know where that is.
Really?
On where? Weather.com?
No. Weather.com. It's the website you're on right now. It's the thing where you see the blizzard warning on.
Okay.
Right above that, it says local weather.
That's where you are. I was right.
Yeah, no, no, no. Okay. I want you to wait,
Dense fog advisory.
what the heck was that language?
Huh? What do you mean?
I don't know. I saw something.
What language?
I don't know. It was on. I don't know. I don't know. You search up something in a different language.
No, I didn't.
Oh, look at Tuesday. Look at Tuesday night into Wednesday. Severe thunderstorms of all things.
Yeah.
Needs to be snow. Well, it might. I can't determine if I should be confident about this or not. I don't think so.
Wednesday. Showers and possibly a thunderstorm. Some of the storms could be severe.
Yes, sir. Yes, sir. Okay, do you know how to check that one forecast thing? Scroll all the way down until you see a map that looks kind it's complicated to explain.
Which one?
Um, are you still in the forecasting where it says Livingston, Louisiana? Andy,
Yeah.
scroll down with your mouse. Scroll down.
Yeah.
Okay, okay. Do you see where? No, stop, stop. Do you see where it says chance of precipitation?
Mm-hmm.
Click on that.
Mm, I don't see the chance of precipitation. No.
No, you're not. No, Andy, you're not catching on what I'm saying. Okay, you see where it says chance of precipitation. It's on the bottom, and you look to the right.
Chance of precipitation is 90%.
No, Andy. This is so complicated. Oh my gosh. Uh,
Hold on, let me see.
let me take a picture of it so I can send you it.
Okay,
It
is
is
it?
it is literally so easy to go to this. I've been trying to tell you this is where you need to go. This is where you need to go. Chance of
Oh,
precipitation.
I see it.
Do you see it now?
Mm-hmm.
Click on weather. Click on the arrow. And go on and just keep going until you can't go no more.
I'm here. Chance of precipitation.
No, no, no. Andy, look, look. Oh, look at the messages I'm sending
Whoa!
you. I am sending you pictures.
My phone
Now,
fell.
now, go to weather, 4 a.m. Then go to the arrow and just click, 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 click until you can't click no more.
4 a.m.
Yeah,
Precipitation.
4 a.m. Yeah, no, 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 no. Weather. Do you see the word weather?
Yeah.
Hover over the word weather
Yeah.
at 4 a.m. And then use your mouse. Do not hover. Don't hover any of those options that says temperature, dew point. Use your mouse. Go all the way to the arrow on the right side where it says next image. You know how to do it?
Yes.
You know how to do it?
Mm-hmm.
Oh, I want to see if you actually do it.
Ooh, severe.
Ah, I can't wait. Oh wait, nothing's gonna happen.
Boom.
What? What?
4 a.m. in the morning.
4 up 4 a.m. in the morning. Ain't no way.
Severe weather.
I know people. I know people ain't gonna be tuning in at that time of the morning.
Well, boom.
Eek, look at all that red. That's scary looking.
That's just a forecast, Johnny.
Mm.
Mm-hmm.
Well then, you have right now. Oh man, you went down to 3 people watching, but I mean, hey, people are still watching you, right?
Thanks, Johnny.
I told you I'd help. There you go. Now you're getting. Oh, dang it! I want to see the rest of it. You keep flipping back to the severe weather thing.
I'm hot, Johnny. I feel really hot.
Well, step outside for a second.
Hold on. I got it. I'm opening the window.
Okay, well, I meant to say was, how long do you think you can stand outside? Average view duration, 4 minutes and 59 seconds. That's pretty good, Andy.
Whew. It's still snowing outside a little bit.
Oh, wow. That's pretty flippin' neat. Oh my gosh, that's very neat.
Oh my god.
Andy,
Hold on.
Andy, this phone's about to die.
Yeah, anyway, I'm waiting for the Euro model.
All right. I'm still gonna be watching you. I'm just gonna let my phone charge.
Okay, the Euro model's coming in.
All right.
I'm only waiting for it to load about this storm. I really hope it goes further south. Yeah, I don't like what I'm seeing here. Yeah, you see this little piece of energy here? As it pivots around, it's going to create this little system. So Tuesday, Sunday, and then Monday. So like literally just moving really fast. Okay, so Sunday it comes ashore, and then it leaves like the coast like Wednesday night. So comes ashore Monday, so 2 days. So that's a pretty fast moving like 50, 60 miles an hour. And a little system would form that storm there. Thank you for joining. Everyone, thank you. Thank you all so much. All right. So it's actually a little further west here. You know what's so funny? Right here. This upper level low is actually further west here. And yet in this is I want this so bad. Even though New York City is not going to get a lot of snow if this were to happen, it would still be really, really nice if this were to happen. Because New York City would still get some snow. Some snow is better than no snow. Here's what would force the storm to go further south. Let's look at the North American continent here. So this upper level low in this system that gave us some snow today will pivot down, right? And then this piece of energy here in this high pressure system will force the storm to go south because this is opening a path for this storm to go further south. Why are the current models saying it's going to go further north? Here's why. So even though you're having a stronger system here, so let's go to hour 117, right? And let's look here. So the big difference is that this system here is further south, but then this system also pulls this high further west. So if you look at this, boom, boom. But over here, you have this cold pattern here, right? So watch this upper level low here, right? This upper low starts kind of dragging it south, and this high pressure system here forces this little piece of energy of lower heights to go down south, right? And forces this storm to go south. But here, that doesn't really happen. Look at the big difference here. Boom. Doesn't exist, right? See this zonal flow here? Let's see what's changed between this run and this run. Here and here, everything's the same, right? But this is a little different. See, right here, you see how this wasn't closed? Piece of this wanted to break off. So, look what happened here. And then, here's what changed. See? Even this is further north. See, further north, even further north. So this piece of energy does not interfere with this system here, allowing this system to go further north. Bingo, and then see. And so this little cutoff flow wants to follow the jet stream. And then look, hour 60, right? I mean, it's a little further west here. So based on what we're seeing here, it's easy to conclude that this system it's a little stronger here. It's a little bit stronger, just a tad stronger. But it's still easy to conclude that even with this piece of energy being further south, see where the center of this system is here, just south of Nova Scotia, right here. But now it's a little bit further southwest here. But here it's moving west here. And at this time here, it was going north, so it was kind of re-looping itself. So you have this little high here. That little 510, 5610 height here. But this is not the same as surface heights, like the 5700 line that we associate with tropical air. This is also heights, but this is looking at 500 millibars. This is not looking at surface heights. That's based on temperatures. This is based on air pressure, but also temperatures too. But like also temperatures, but this is looking at heights at 500 millibars, not at the surface. So look at the height line here. See, and it looks completely different here. Wow, like completely. Both of these systems are in the same position, but the major factor is this little piece of energy. It looks very inconspicuous, like very inconspicuous. Looks like, oh, little piece of energy. But that little piece of energy, even though it dissipates, allows enough cold air, forces this high pressure system here to basically sit and spin over this low, and then all this cold air forms and forms a big block, forcing the storm to go south and then off the coast. But here, this doesn't exist now, right? It still tries to form, but look, this high here just moves east, right? See? Let's look at hour 144. Completely different. Look where the high is here. See? So even though it's further south, look what you had over here. So it looks a little different, just a little bit, but not much. But it's still kind of doing the same thing it was doing before, which is that it's actually even further east here. See how it's shoving further east? See how this low is closing itself off? See, this high is even further east here. But now, even further east. So, what made this system? What made this big change here between the 12Z here and here? If you were to look here, what forced the system to go south was this little piece of here. See this swirl here, kind of piece of this system here. But look, so a big change here. This is further east, while this system here is right and actually even a little further north. So this is actually meaning that this system might actually even go further north now. You can see how you're even having a warmer advection here. You're having warmer advection. Here you weren't really having that much warm advection. But look what's happened here. Look at the temperatures here. Look at the amplitude of the winds at the surface. Now they're very sharp, so you're having all this warm advection coming in. Not only that, but this high pressure system aloft is further east, meaning even though it looks like it's trying to elongate, potentially move further south, this is also starting happening here. But then it got lifted north by this trough. And when did that start moving down? This little piece of energy started. And look, it's already starting to happen. You see that here? It's already starting to lift down, even sooner than what the other model is predicting. So it's pretty guaranteed that what's going to happen is, as this digs down, this will, the amplitude will, so the sharp amplitude here will force the system to drive north unless something happens with this high here. But look, it's being broken up somehow, so it's pretty certain that this system here will end up and that's a polar vortex there. That is definitely a polar vortex. Ooh, wow. Like, let's look at surface temperatures because this is going to be in the negative 10s and 20s here. Yeah, that's a polar vortex. See those white temps? Those white temperatures. Continental US. Negative 16 degrees. Negative 8, negative 12 during the day. I mean, it's not the worst I've seen it, but still, that's very cold. So, the amplitude is probably going to be even sharper now. Yep. There you have it. It's even further north here. As this digs down, I mean, this could mean this could drop further south, or it could very well just, yeah. Let's see if it's similar to here. Yep, and here's the surface low here. So it's going to be raining in New York City. Yep, so New York City is going to get rain from this, and then behind the system is going to get cold. Not immediately. It's not going to immediately get cold. Basically, you're going to have some cold air on the backside. Then you'll have like an Arctic front that'll come through, so you'll get cold. So there'll probably be some 20s in New York City, probably lows in the upper 20s, low 30s. Yeah, so it's still like about a few. It's still like five days out. So the pattern that's going to lead to this is probably already 3 days out. So I mean, it could still change in a couple days, but it's pretty much set in stone what's already going to happen. And there's a piece of that cold air coming in. So this is kind of pivoting around that little piece there. Yep, so it cuts off. My thinking is that this will dip south and big polar vortex will form somewhere over the upper Midwest. But based on what I'm seeing here, something definitely is going to happen. I mean, this is crazy cold. So the further north, so you're having a very, so you're starting to have a positive PNA develop right here. Let's look at 700 millibars. So warm weather starts going into Alaska, and you start having a strong low pressure system developing. This, in turn, will cause this low here to drop down here, or it could stay up here, but most of the models were saying that it's going to drop down. So yeah, you see how it's starting to wrap up here? Yeah, so you do have a pretty strong polar vortex. I mean, look at those heights. That's 5040. You know, 5100, 5070. So that's actually 5030. That's a very strong height line. Those are very low heights, and like, yeah, that were to happen here, wow, that would be insane cold. Let's look at the surface. I mean, that's definitely a little bit of a surface low, but always when you're having such heights, your lows or your surface low would not be right, would be stacked, would be here. See, as you go lower, so your height is never, your surface low is almost never stacked right on top of one another. See, it's always a little, there's always displacement a little bit to the east. There's always slight displacement eastward. See? And then at the absolute surface, the surface low would be here. And this is where a lot of your precipitation would be. Ta-da! Of course, this would be mostly snow, obviously. So this is basically an Arctic low. But it's part of this system here. This is evidence of a negative NAO here. That's definitely interesting here. That is definitely interesting because guess what? That wasn't there. This is almost similar to what the GFS was showing here. About our so it's kind of similar to what the GFS was showing. Um, ooh. I mean, if this dips far enough south, I mean, if this goes like, say, okay, I want to go here, and then, yeah, that would be nice. Keep in mind, it's being displaced further north. So let's look at North America here. So basically saying that okay, maybe a little bit of snow in the inland areas because it will, because even though the surface low initially starts out in the warm sector, as this low becomes dominant, it will still have some cold air to work with, but not that much cold air. Ooh, not good. Let's see. Ooh, yeah, definitely. Wind, hail, tornado. Woo! Yeah, I'm very worried about Alexandria. So your wind threat is maxed out. Tornado. Shreveport, Bossier City, Monroe, Alexandria, Marshall. So Bossier City, Bossier City. It's not Bossier, it's Bossier. It's Bossier City. I think that's the correct pronunciation. It's Bossier, Bossier, Bossier City, Bossier City, Monroe, Alexandria, Marshall, Texas. Hail threat, 15%. I think that's a little too high. I would put it 5%. All right, so going back at the models, I kind of agree with that enhanced risk, especially with what I saw in the HRRR. Let's see the new HRRR. Whoa, supercells. I did not see that here. I mean, it didn't look as bad. This looks a little more vigorous. Okay, let's look at the euro again. All right. Let's look at the 500. Definitely looks different. So further south, and then a piece of energy is coming down here. So this definitely does look a little different. A little bit, but not by much. So you're having a coastal low here. So this is the original dominant low here. And then you have the Appalachian low form on the east side of the Appalachians, moves up the coast. Because this storm dies out, and then you have a secondary low forming along the coast. Because as the storm goes near the Appalachian, it weakens. but you still have a lot of vorticity here, and that vorticity helps form the secondary area of low pressure. But it's kind of cold along the coast. You might have a little bit of snow in Maine, looking at 925 millibars. It's not going to have any snow for New York, but some snow for Maine is possible from this. Not a lot, but some snow. And that's some cold air aloft snow. There, some convective precip there. See that little cold pocket aloft? I'll definitely have some snow with it, some convective precip. Yeah, it definitely looks a little different here. Yeah. It actually looks a good deal different. I mean, some if this happens, something major could happen around hour 180. Yeah, this is a little stronger here. We actually may get a pretty good coastal storm here. Probably rain, but still. This piece of energy will definitely form a coastal system stronger, as you're having this piece of energy coming down. Oh, something major is going to happen. Something major indeed is going to happen. Let's see. I mean, this is not going to happen. I can guarantee that. See that little bit of a ridge here? As this will dig down, you will get a bit of a ridging here. Okay, let's look at 12Z for a good prime example. See how you start to have this southwest flow because you're on the southeast side of this polar vortex. That's kind of what's going to happen. You see how you're having this westerly flow here. Here the flow was again westerly. We actually might be more on the east side, but we might be on the southeast side of this low. I mean, this is looking very complex. This is currently developing as we speak. So things are definitely getting interesting. Thanks. Echo. Okay. Oh, I think I figured it out. Okay, hold on. Monday about the severe weather. I have a question that because here it is. Why doesn't temperature matter? Why doesn't temperature matter in this case? Because where the severe risk is like at only so basically, even if temperatures are in the 50s, you can still have severe weather, especially if your lapse rates are steep enough. So yeah, it's definitely possible. So lapse rates is the rate of which a parcel lifts before it cools to the same temperature as the ambient or the actual temperature. As long as an air parcel is warmer than the environmental temperature, it will continue to rise. But if it's cooler, it will sink. A cooler parcel of air, if it's cooler than the environment, it will sink. If it's warmer, it will rise. So if your ambient air temperature is 86 degrees, for example, but your air parcel is 90, it will rise until it reaches equilibrium. And a temperature differential between the air parcel and the temperature is known as the that's the temperature differential. And the area between where the air particle lifts and stops lifting is called the area of lifted or LFC, level of free convection. And that's where you have your convection. But it's not just the temperature gradient alone that determines the severe weather. There's also lift factors. So it's more than just, oh, okay, you just have a temperature gradient. I mean, if you have a steep enough lapse rate with no storm system, you'll still get precipitation. You could get some. See, as you're getting this system here, so you're getting this low here and this low here. So what will end up happening is, as this digs further south, you'll start to get a southwest flow here, and this will kind of ride along like this. And you'll start to possibly have a kind of a westerly flow. But the chance of a coastal storm is now increasing. So we could get something on the East Coast if this indeed transpires. But you see, you're starting to have it a little bit of a warm advection again. Because you're getting this area of low pressure here. So what you're getting is, as this low lifts out and this low sinks in, you'll start to have some warm advection as another trough. So you're going to have area of low pressure moving out, high pressure will build in, you'll have a high here, and depending on how far, where the trough sets up, if this trough axis is further west, you will be on the warm sector of the trough. If it's further east, you'll be on the cold sector, or depending on where the axis sets up. I mean, this is different from all the other models, so see, you're still having this northwest flow. So it's pretty safe to say this is probably going to be a rain event for New York. Even though it looks like, oh, look at all that cold air coming in. Keep in mind, you're having this system forming here, and you'll have warm air. In fact, you see that southwest flow here? See cold air forms, and then look, see how temperatures are warming up here in southern Missouri as this cold air sinks in. So you're basically starting to have a surface low forming here in eastern Colorado. So let's now look at the continental U.S. So low lifts out, cold air sinking in. And already, look, you're starting to have a bit of a trough setting up. I mean, a bit of a ridge. Look. So as this kind of lifts up north, what will end up happening is, yeah, New York City's going to get rain from this system. It's already pretty certain what's going to happen. As this trough comes in, you'll start to get a ridge building in, and this 5400 line, as the system forms here, will end up going up the coast, and New York City will end up getting rain. Yeah, this line will end up probably going north of New York City, most likely. I mean, I could be wrong, but knowing what I know, it's pretty certain, based on what I'm seeing here, the amplification, it probably will go north, and that will mean rain for New York. And that's basically a piece of the polar vortex here. And here it is coming down. I mean, it really wants to come down here. Here comes the warm convection. And it's coming in before any precip comes in. But now you're having your precip. And you're going to have a low surface form in the Gulf. I mean, you're going to have a surface low forming somewhere, in the Great Plains region, probably North Texas, southern Kansas, this area here, and then probably go north secondary for slow form somewhere along the East Coast. Still will be mostly rain. I'm just basing this on what normally happens. So imagine this, but further west. So you'll probably get a lot of storminess on the East Coast. And that's when the amplification was only like this. But here, the amplification is even sharper. So does it look like New York City is going to get rain or snow from this? Doesn't take a genius to realize that this is probably going to be mostly rain for New York City. I mean, see how it's already starting to, you're starting to get a warm air advection coming in here. You're having a southerly flow. Look at that. Classic Gulf of Mexico flow. Cold air coming into the Rockies. This is a negative AO. I mean, yeah, you're having a negative NAO, but the NAO is not negative enough. If it was really negative, this would be forcing south. But the NAO right now is forecast to be neutral. It's even actually going positive a little bit, then it's going back down to like slightly neutral. Like, even though the NAO is negative right now, it's not negative to the point of having major storms. But with the AO being negative right now, as negative as it is, a storm is definitely possible. Okay, so let's look at this again. Looking at 500 millibars, right? So your amplification will continue to increase. Your warmer temperatures will move further north. So you'll have pinks probably in Kentucky. So Kentucky's starting to have pinks. Well, that's what's happening in North America. I mean, look what's happening to the polar vortex. It's strengthening. I mean, this is a piece of the polar vortex. It doesn't look anything like this. This is a classic La Nina setup, by the way. But the only difference is that the South is getting quite a bit of rain. But you're getting a lot of dry weather here. But so I was absolutely right about my thinking. Rain from New York. This is going to be absolutely a warm system. It's going to probably be a little cold at the onset, and then it will quickly transition over to rain, and maybe there's a little bit of snow, but that's only what I'm thinking based on what I'm seeing now. This is not saying, okay, this is going to happen. This is just based on what I'm seeing. So here's your low at 850. Your surface low, however, is a little further south, but still. It's like, oh look, it's moving east, right? And where's your high pressure system? Here. It's not a blocking high here. Your high is here, right? Your wind's here from the southwest. I mean, you're also having a high over here, but it makes sense. You have a high here, so you're going to have a low here, and so you're going to have southwest winds. As your high moves east, the winds will switch around to the southwest, and so you'll have warm air coming into New York. Like, look what happened here. So cold air came in, and as the trough amplitude happened, increased, and a low pressure system formed in the east of the Rockies. So look, yep. And where's the secondary low going to form? It's probably going to form somewhere east of the Rockies. Will probably produce rain. I mean, this is normally what happens around this time of year. Even though it doesn't look like, okay, even though it doesn't look like this, it's still going to be a warmer system because your surface low is here. And the amplitude, as this trough digs, the amplitude increases, which means more warm air is emanated back north. Let's look at 700 millibars for instance. This is the freezing level at 700 millibars, or 10,000 feet. It's roughly 10,000 feet, give or take a few hundred feet depending on the thickness. But it's roughly averaging to be around 10,000 feet. 850 millibars. Look at all that warm air advecting northward. And let's look at 925 now. Johnny's calling. Johnny?
Hello, buddy. I'm still watching you watching.
Yeah.
I've been watching you watching this entire time on my TV, and
Thanks.
you're providing a very good coverage.
Thank you, Johnny. Okay. So yeah.
Okay, I need to tell you something.
What?
There is somebody that I used to go to school with. His name is Hollywood Lee, and I mean,
Johnny, I'm live. People are gonna hear this.
oh, okay.
Oh, let me mute the stream. Hold on, so nobody hears this. 2-1. All right, I'm back. Here comes the warm air advection, New York. As I said, rain in New York City. Ooh, maybe some severe weather for the South possible. Ooh. Yeah, La Ninas are not good for the South. This will definitely create some severe weather. And yeah, I know it's echoing. Yes, it's echoing, Johnny. I think I know why. Okay, hello? Uh, okay, hello? Okay, how is it echoing now? Testing, testing. Johnny? Testing, testing. It always does that. It always does that, Johnny. Probably because of me. Alright, so. Yeah. Even the GFS is hinting on that. So the Euro is showing this system going to New York. Oops. Ugh, unbelievable. A true inland runner. A lake effect palooza. That's a lot of lake effect. Wow, look at all that cold air on the backside of this system. Not a coastal storm, that's just level. Interesting. Oh, this is interesting. Ooh, that looks interesting. That's. That's a little concerning. Okay, here comes the H triple R. Hold on. Here comes the H triple R, Johnny. The 18, the 60. Okay, I gotta go to bed. Southeast. I mean, south. No, let's go Southern Great Plains. Whoa, supercells in Alexandria. It's definitely a little concerning, especially for overnight Tuesday into Wednesday. All right, thank you all for watching. Good night, everyone.